Right, for this lesson, we have lesson 233, locked rotor current and phase loss for motors, AC, and refrigeration equipment, fire pumps. I think we can keep this video a little bit light. We're going to go over how to use a couple of formulas. Otherwise, the textbook does a pretty nice job summarizing everything. So a couple tables we need to reference here. In this case, table 430.7b is going to tell us locked rotor currents by letter code. 430.251a and actually .251b are going to be single phase and three phase respectively. That's going to tell us locked rotor currents by NEMA design letter. So we need to be careful. Sometimes in some of these problems we'll be given a code letter. In other cases we'll be given a NEMA design letter or just a design letter. Make sure you make that distinction. Because we are going to use different tables depending on what information is given to us in the type of motor. So just to have a look, this is your 430.7b motor locked rotor currents by code letter, and then here we see 432.51a, which is going to be single phase when we have that NEMA design letter. And again, we're going to look at an example with each table, and then here's the same information but for a three-phase motor in your 430.251b. So, once again, I just want to kind of handle some how to use some formulas, use some tables. I'm going to let the book do the rest of the explaining because they do a nice job. So let's dive in and do an example here. In this case, we have a motor nameplate here. They tell us it's a 3-pole breaker and a 120 240 volt three-phase panel. So in this case, because we have this letter code J, we're actually going to use, and your textbook gives you this formula, but essentially our locked rotor current, if we have this letter code version, we're going to use the information, the kVA from the table, and that's going to be per horsepower. So for each horsepower, that's how many kVA we're going to have to include. We multiply by 1,000 because it's kVA. We want to take it back to simply VA, or volt amps, so we can apply our Ohm's law formulas. Then we're going to multiply by horsepower. So if we think about this, just this top part, this is the kVA per horsepower. We multiply by 1,000, now it becomes the VA per horsepower. And then we multiply by however many horsepower we have. So that's going to tell us our total volt amps for the motor we're working with. And then we're going to come in here and we're going to divide by our voltage times 1.732 if it's three-phase, and it is. So really, we're finding amperage. If you think about this, it's just kind of a fancy way to use Ohm's law. We're going to find our total volt amps. So we have kVA times 1,000 because it's volt amps, times the amount of horsepower because it's volt amps per horsepower. So now we have 1 volt amps. We divide by volts. We are left with amps. In other words, we can say watts divided by volts equals amps, right? So whether you wrap your head around that or not, and I hope you do, this is the formula we are going to use to calculate this information. So what's the locked rotor amperage for this code letter J motor? So there we need to know it's a letter J. So we come over and check 430.7b, and we know down in the J row, it's going to tell us our kVA per horsepower is 7.1 through 7.99. The book is going to direct you, correctly to use the highest option in each row here. So we're actually going to use 7.99. We're going to plan for worst case scenario here. So let's come back and plug that into our equation here. 7.99 times 1,000 times horsepower. So next step, we need to know that it's a 15 horsepower motor. So let's go ahead and plug that into our equation here. And it's a 230 volt rated. We're running it at 240, so we're going to use the 230 volt value here. So we plug that into the bottom of our equation, and now we can simply solve for our total value. So we would have locked rotor ampacity of 300.859 amps for this code letter J motor. So let's look at sort of the other side of things. In this case, we're going to look at that NEMA design or that design letter rating. So in this case, we have a three-phase, 10 horsepower, 230, 460 volt design B motor with a nameplate FLA of 26/13. So if we hook it up to 230, it's 26. If we hook it up 460, it's 13. If operated at 230 volts, about blank amps of starting current, or LRC, locked rotor current, would flow in each branch circuit conductor. So what's the block rotor current is what all that boils down to. We need to know a few things. First of all, it's a design B motor. It's a 3-phase motor, 10 horsepower. We're going to run it at 230 volts, so therefore it's a 230 volt motor in this case, and because of that it'll be a full load amp rating of 26. So let's go over again, since this is a NEMA design letter, we're going to use table 430.251 to sort of find this value out here. So we did say it was a 10 horsepower, we did say it was 230 volts, so naturally that leaves us to select this 162 amps for our value. So there again, not a lot of math there, it's just a matter of sort of knowing the table that you need to check and how to use that. And keep in mind, that's for the 3-phase motor here. If we were going to use our single-phase motor, we would be back here, all the way back on, bear with me, 430.251A rather than 251B. So again, textbook does a nice job of breaking all this down. Be sure to read through that. Tried to pull out some of what I thought was the more difficult mathematics, formulas, table usage. But again, I think pretty straightforward as long as you make sure to read that text carefully.